this is going to be a little video about the composition of functions. This is basically just putting functions inside of each other. So if you think of it like machines, if you have your input x and you put that into machine f, you're going to get out the output f of x. So then take that output and put it into machine g, and you're going to get out g of f of x. So this can be written in this format, which means you would plug g into f. The g function would go into f. Or if it's written this way, reverse, then you'll just plug the f function into g. So it's pretty simple. It makes sense if you have kind of an example to work with. So we'll just do number 1 off of problem set. I think it's 38. 38, which gives us f of x equals 2x minus 3 and g of x equals negative 5x plus 4. Oops, whoopsie. And we are asked to find g of f of x and f of g of x. So we're going to start with this here, which means we're going to plug the g function into the f function. So anywhere that there is an x in the f function, we're just going to put this in there instead. So we have 2 times, that would be x, but we're going to use negative 5x plus 4, and then we can't forget our minus 3. So that's going to distribute and be negative 10x plus 8 minus 3, and then combine those like terms. So our final answer is 10x plus 5. Go ahead and put that up here. Negative 10x plus 5. So then we'll do the second one. So it is reversed this time, so we're going to plug the f function into the g function. So g is negative 5 times x, but we're not going to use x. We're going to use 2x minus 3, and then can't forget our plus 4. So we'll distribute that negative 5, and we get a negative 10x plus 15 plus 4, which, if you combine like terms, is negative 10x plus 19. So those are going to be our final answers on that first problem. Super easy. You can take it a step further. Over here, your book talks about finding the domain of g of f of x and of f of g of x, which is going to be just like finding the domain of a normal function. So we'll practice one of those problems from the problem set. Problem number 2 gives f of x equals 3x plus 1. And g of x equals 1 over 2x minus 5. And first it asks for the domain of f. So we're simply looking at the f function here. And is there any value that we could plug into x that would make this function undefined? The answer is no. You could put all real numbers in there. So our domain is going to be negative infinity to positive infinity. Then it asks for the domain of g. So we need to look here at the bottom of the fraction. Is there anything we could plug into x that would make this function undefined? And the answer is yes, because if we multiply 2 times, 5 halves, and then subtract 5, then we'll end up with a 0 on the bottom, and that is just no good. So our domain is negative infinity to 5 halves, and then 5 halves to positive infinity. So we're excluding that 5 halves. So the next thing that the question asks us is to find g of f of x. So that's going to be written like this. So we are going to input g anywhere there's an x in the f function. So we're going to do 3 times 1 over 2x minus 5 plus 1. That's going to simplify to 3 over 2x minus 5 plus 1, which further simplifies to 3 plus 2x minus 5 over 2x minus 5. And then we'll combine those like terms, and we will get negative 2 plus 2x over 2x minus 5. Just like that. So now it is asking for the domain of g of f of x. So the domain, we're going to again look at the bottom of that fraction, and it is the same as the original. The bottom of the fraction is the same as the bottom of the g of x function. So our domain is going to be the same. It's going to exclude that 5/2 value. Okay, next it asks for f of g of x. So we are going to input our f function anywhere that there's an x in the g function. So 1 over 2 times 3x plus 1 minus 5. And that's going to distribute, and we're going to be left with 1 over 6x plus 2 minus 5, which further reduces, once you combine like terms, to 1 over 6x minus 3. So it asks us for the domain of this function, and we're going to again look at the bottom and think what x value would make this problem, or make this function undefined, and that value is going to be 1/2, because if you take half of 6, you're left with 3, and 3 minus 3 is 0, and that cannot be on the bottom of the function. And that is the whole problem 2. Problem 3 is very similar. It just adds in some square roots, but it's the exact same thing. You'll input g and for any x value in the f of x function, and then reverse it and do the same thing for f of x, put that into g of x. So number 4, that, let's see, if I can just scroll through it. Number 4, that's down here. It asks us to determine functions f and g such that h equals g of f of x. Do not use identity function for f or g. So it's basically wanting us to find we have to figure out what the two functions are given this function h of x. We have to determine what the two functions were that combined to create this. So we have to remember that when it's written like this, that means g is going into f. So we're going to write f of x here and g of x here, and we're going to look at this, and we're going to see what is the deepest inside this problem, what seems to be plugged in. And to me, it looks like x cubed minus 2 is plugged in because it's underneath this radical. It seems like it's the deepest inside this equation. So since that is what was plugged in, and g is what we're plugging into f, x cubed minus 2 must be our g of x function. So whenever we were plugging in, we were putting this wherever there was an x function in f, so that must mean that the f of x function is the square root of x, because if we were to plug that in, it would be the square root of x cubed minus 2. And that is our h of x function that we were trying to unravel. The next one, it says h of x equals cosine 6x minus 3. So we'll put our f of x here. And it's the same thing. G was being plugged into f, so we kind of look at what seems to be the deepest inside. And I'm looking in here inside these parentheses, 6x minus 3. That must be our g function. And since that was plugged in, that must mean there's an x inside that cosine parentheses. Just like that. And then the last one, it says h of x equals 1 over 4x squared plus 7. So let's look and see what is the deepest inside that equation. And to me, this looks like it's the deepest in there. So I'm going to say g of x is equal to 4x squared plus 7. And then that must mean we had an x underneath that fraction bar. And that, I think, yep, that is the whole problem set 38. And yeah, that is composition of functions.